This is about concentrations of solutions, and there's 4 different ways you can represent concentrations. It's going to be mass percent, volume percent, mass volume percent, and molarity. So for mass percent, they already gave it to us. It's just the mass of the solute over the mass of the solution, and then you multiply that by 100% to give you the mass percent. So for example, when converting the 10% mass over mass sodium chloride, you would write it as a conversion factor as 10 grams sodium chloride divided by or over the 100 gram sodium chloride solution. And then you can also write the inverse of this depending on what you're trying to find using the conversion factor. You can write it as 100 gram sodium chloride solution divided by 10 grams sodium chloride. Then for volume percent, it would be volume of your solute over volume solution multiplied by 100%. So if we wanted to write that as a conversion factor, if they give us 95% volume alcohol, you would write that as 95 milliliters alcohol over 100 milliliters solution. And then we can also write the inverse of this as 100 milliliters solution over 95 milliliters alcohol. Another concentration unit we can use is mass over volume percent, and that's just combining them. So it's the mass of your solute in grams over the volume of your solution, and that's going to be in milliliters, times 100%. An important thing to note is that we always use grams over milliliters for mass volume percent, so if they give you liters, make sure you convert that to milliliters or you won't get the same answer. And then for the conversion factor, if you're given 20%, this should be an M, mass over volume, sodium hydroxide, you would write that as 20 grams sodium hydroxide over 100 milliliters sodium hydroxide solution. And then you can also write the inverse again as 100 milliliters sodium hydroxide solution over 20 grams sodium hydroxide. So the last concentration unit that's used is molarity, and that just translates as moles of your solute over your volume of your solution in liters. And molarity is represented by a capital M, and then also for volume you also want to make sure that it's in liters, not milliliters. So for example, for a conversion factor, 12 moles HCl translates as 12 moles HCl per 1 liter HCl, or 1 liter of HCl per 12 moles of HCl. So for the first problem, it's asking for the mass percent of sodium chloride in a solution made by dissolving 2 grams of sodium chloride in 56 grams of water. So we're looking for the mass percent, and we know that the volume of the solute is 2 grams NaCl, and they're adding that to 56 grams of water. So the volume, or the mass of your solute, is 2 grams NaCl, and the mass of the solution is going to be the 2 grams plus the 56 grams, because the entire solution is the NaCl plus the water. So that's why it's going to be 58 grams NaCl solution. And you're going to multiply that by 100%. And when you do that, it's going to give you 3.4% mass over mass NaCl. And then we want it to be rounded to 3.4% because the lowest amount of sig figs is the 2.0 grams, which has two significant figures. So this problem is asking for the volume percent of bromine in a solution prepared by dissolving 12 milliliters of liquid bromine in the solvent carbon tetrachloride to make 250 milliliters of solution. So volume percent we know is the volume of the solute over the volume of the solution. So the volume of the solute is the 12 milliliters liquid bromine over the entire solution, which they give us as 250 milliliters solution. And you multiply that by 100%, which will give you 4.8% volume over volume bromine. And then again for significant figures, we want to have two significant figures because the 12 has two significant figures and the 250 also has two significant figures. So for part D, it's asking for the mass volume percent of sodium hydroxide in a solution prepared by dissolving 12 grams sodium hydroxide in enough water to make 250 milliliters of solution. So they give us the milliliters of solution and they give us grams of sodium hydroxide. The grams of hydroxide is our solute and it's already in grams, and then the volume is already in milliliters. So we just take the 12 grams sodium hydroxide, the solute, over the 220 milliliters of the entire solution. Multiplying that by 100% gives us 5.5% mass over volume. And then significant figures, we have two significant figures once again because 12 grams, two significant figures, two sig figs here. So that's our answer. Part E is asking for the molarity of a solution that contains 75 grams of KNO3 dissolved in 0.350 liters of the solution. So notice for molarity we need moles over liters. They give us grams, so we have to convert the grams to moles using molar mass. So 75 grams is our given. Molar mass is 101.11 grams in 1 mole KNO3. That gives us, grams cancel out, divide 75 by 101.11, and we get 0.7418 moles of KNO3. And then they give us that the volume of the solution is 0.350 liters. For molarity, we need moles over liters, so that's perfect. Just put the moles over the liters. Solution. And that'll give us an answer of 2.12 molarity. So for number 2, it's a dilution problem, so it's telling us we have a stock solution of 4 molarity KCl, and they want to make a diluted solution of KCl with a concentration of 0.250 molarity KCl. So the first concentration, well, for dilution we use this equation, C1 times V1 equals C2 times V2. C1 and C2 are the concentrations, and the V is the volumes. So concentration 1, they tell us, is 4.00 molarity KCl, and the second one is 0.25 molarity KCl. If we need 0.750 liters of the diluted solution, how much of the stock solution do you need? So the 0.750 goes with the other diluted concentration, so that's going to be volume 2 liters. And then so it's asking how much of the stock solution do you need? So we know that this is what it's asking for. So plugging into our equation, concentration 1, 4.00 molarity times V1, which is what we're looking for, our C2, 0.250 molarity, and then multiplied by volume 2, 0.75 liters. When we multiply this out, we multiply those, and then to get V1 by itself, divide by the 4.0 molarity for both sides. These cancel out, giving us V1. Multiplying those, dividing by 4, molarity cancels out, giving us liters. And therefore, the answer is 0.0469 liters. And notice that we have 3 sig figs, because the lowest that we have is 3 sig figs. So this last problem is also a dilution problem. It's asking for the final concentration of HCl when 555 milliliters of 3 molarity HCl is diluted to 1.5 liters. So our stock solution is basically the 555 milliliters and the 3 molarity HCl. So concentration C1 is the 3.00 molarity HCl. Volume 1, notice that it's in milliliters and our dilution is in liters, and molarity uses moles over liters, so it's best to convert the milliliters to liters. So to do that, we take 555 milliliters, using the conversion that 1,000 milliliters is equal to 1 liter. That'll give us 0.555 liters. These cancel out. So our volume 1 is 0.55 liters. Okay, and then our concentration 2, they don't give us, that's what we're looking for. And then the volume for that is 1.5 liters. So using that, we plug it into the dilution equation. C1, 3 molarity, volume 1 liters is equal to our C2, which we're looking for, times the volume 2, which is 1.5 liters. To get this, to get C2 by itself, we divide by 1.5 liters. C2 equals 3 times the 0.55 liters divided by the 1.5 liters. Liters cancel out. Putting that in your calculator will give you 1.11 molarity HCl.